Hey folks, welcome back to the shop. Frank here, continuing to work on the Cub Cadet articulated dump truck 4x4. Last week I mentioned that I wasn't really happy with the lifting capability of the dump bed. I'm kind of stuck with the geometry on the cylinders. The limiting factor at this point is the hydraulic pressure coming from the auxiliary ports on the hydrostatic transmission, which is 600 psi. So I really don't have the lifting capacity that I'd like, so I've decided to add a hydraulic pump. This was always kind of, a fallback position for me on this build. I was hoping I would have adequate pressure, but I clearly don't. Under different circumstances with different geometry on the cylinders, you might be able to live with the 600 psi, but it's just too restricting at this point. Plus, it also prevents me, the low pressure prevents me from adding other attachments to the tractor. I'm thinking about a 3-point hitch, a category 1 3-point hitch on the back of it. So adding the hydraulic pump will solve a couple different problems and give me some capabilities, in the future for other attachments. So that's what I'm doing now. This episode, we're going to mount the pump. I've got a couple of parts I've already modeled in Fusion. We'll cut them out on the plasma table. We'll fit them up to the pump. This is, for those of you, this is what the pump looks like. I mean, this isn't the exact pump, but it's identical to the one we're going to use. So this one has too much displacement, too large displacement rate for our purposes at this point. This is a 6 GPM pump. What I'm going to use is a 2 GPM pump. 2 GPM at 3,000 RPM. I've got the pump. I think it just came today. I saw the FedEx truck stop and ordered it from northerntool.com, and I think that's what came. But it's identical to the one I've got here, physical dimensions. So we'll work with this one for the time being, and we'll fit the stuff up to the tractor and show you how to do it. It's going to be pretty straightforward. And actually easier than many of the other possible solutions, which I considered were bigger cylinders, a different arrangement of the cylinders, things like that. All much more expensive and perhaps not as simple to do as this. So heading this direction, so you can see what it takes to hook a hydraulic pump up to a Cub Cadet transmission. So hydrostatic transmission, that is. So I just filled the table, the CNC plasma table with water, so that's ready to go. The air compressor's been running, so the system's charged for that. So we'll cut out a couple parts over there, and then we'll come back, fit them up. And we do need to go to the lathe to make a coupler, so we'll do that as well. All right, that's what we're doing. increased my cut speed. This is the same speed I cut 1/4 inch. This is 3/16. I think it's a little slow because I'm getting slag. All right, so the way this is going to work is the pump will mount to this plate. This plate will fit on here and be somewhat adjustable in its location. So that'll give us the ability to move it around a little bit for best fit. So. I've got a carbide insert countersink. It's a little worn, that insert. I might have to turn it, but we'll see here. The reason I'm using a carbide insert is because the plasma table tends to harden the material, and I think there's a couple factors. One is the nitrogen in the air used as a, as part of the plasma nitrides the steel. At least this is what I've understood. And also, of course, since it's heated and quenched with water in the table, it tends to be tempered that way. So I want to countersink these holes for some flathead machine screws. So apparently, I told a story. This is the new pump. This is the one I just bought. This is the one I showed you earlier. And 3/8 inch bolts go right through that flange. They don't fit through this flange. So either I drilled them out, which is possible. It's probably likely that I did that. Okay, so I need to also countersink these as well so that the shoulder will fit down in there and the bolts will pull up the plate tight. Alright, got the Allen head screws here, machine screws, socket head cap screws. And I'm putting the safety nuts on the back. Now these holes are oversized to give a little bit of play. It's actually going to go together like that for alignment purposes. Alright, so these bolts are longer than I need, but they happen to be what I have on hand. Overkill. The problem is, where I live, I'm stuck with the Ace hardware store, or there's also True Value, where each screw costs a couple bucks, or bulk purchases at the Tractor Supply, which is what I normally do, but then they have, they don't have uncommon sizes. So 1/2-inch bolts shorter than 1.25 inches or 1.5 inches is, unusual, and you don't find them. So, but that's okay. So this will mount then behind the transmission, and we'll couple it to the output shaft. All right, so this gives you a view behind the transmission. This plate. All right, so we just need to make some adjustments to get the two shafts to line up. As with prototyping and test fitting, not happy with this particular design plate. I'll show you what I'm going to cut out next. So this is my new plate design. I made several adjustments. I made this gap at the bottom here wider. This is to be able to remove the oil filter. And then I've formed slots here, so I have more adjustment up and down. I've notched out these top corners, which were just square before, so I have more flexibility in the location of this plate. So these will simplify, fit up, and allow more adjustment range for the location of the pump. I think my location on here horizontally is really close. I mean, within a 1/16, and I have that much adjustment within these slots. But up and down, I was off 3/4 of an inch, so this gives me the ability to get dead on. So we're going to cut this plate next, and it's just easier to cut a new plate than it is to try to modify the existing plate. It's just it's so easy to cut it on the plasma table. Okay, start. Alright, so there's a lot less dross on this one than the last one. I upped the cut speed to 50, and I changed the nozzle. Put a new nozzle and electrode in. So gives a much cleaner cut. I mean, there's a little bit of slag where it pierced through, but much better result. So. So this is a piece of 4140. We'll make our coupler out of this. Let's get a little more speed here. I want about 1,000 RPM. So like 3 high. That didn't work. Oh, that insert's got a little chip in it. Yeah, tiny chip out of that other side. All right, so we're going to go through with the 31/64ths, and then we'll ream it to 1/2 inch. All right, so we've got it reamed to 1/2 inch. All right, for this application, drilling it to 5/8 will be fine. There's a bevel on the outside of this piece from sanding it, so it's uneven, and that's why it looks like it's wobbling. I didn't like the way that worked. All right, that gives us the basic coupler we need. Five-eighths inch on this end, 1/2 inch on this end. We do need to broach a keyway, so we'll do that next. All right, so I found the center between both sides of this coupler. I'm going to drill a 1/4 inch hole. This is the 5/8 inch bore, so this will go to the transmission, and it has a 1/4 inch roll pin. All right, so this is our broaching kit. All right, so that's the bushing. So we need to broach an 1/8" keyway in here. That'll fit the shaft of the pump. So let's find the right broach. 3/16. What's this? 1/8. Okay, so the broach, the shim, the bushing. All right, so we don't use the shim on the first pass. I'm going to push this through. So let's get set up over at the press to do this. Okay, I've got my finger brake in here now, so I need to remove that. So I'm going to lift the table up a little bit, pull the pins. And this is the benefit of having a winch on your table. Let's see what it's hitting something else. All right, so that lets me remove the finger brake. Now this is a vise I just use as a spacer, and I think I'm not going to need it. Let me move it then. Okay. Just needed to push it to pull it the last little bit out. All right, let's do a test fit here. Put the broaching tool away. Broach and the shim. All right, there's the shaft, there's the key. Oh, that's a perfect fit. Look at that. Perfecto. All right. All right, so the next thing I need to do is drill a couple of holes for set screws. Maybe we'll do one on the keyway and one on the side. Since I didn't disturb my setup, I'm able to put the part back in the vise in the same orientation and have it still be centered. Let's turn that 90 degrees. Very careful here. The last thing you want to do is break the tap in this hole. All right, I think we're good on the second one. Okay. I think we're done with this coupler. All right, we've got two set screws, 90 degrees apart, on the spline shaft, and we've got the 1/4 inch hole for the roll pin on the transmission. We'll put some Loctite on these set screws at some point. All right, let's go fit this up. What you guys doing? You've been barking at the skid steer outside? All right, some of you know, as I mentioned in an earlier video, I have contractors here working on an addition to the house, and they're getting ready to lay some more brick and moving a cube of brick around with a skid steer, and these guys are inside the fence. Of course, all that's outside the fence, but these guys are inside the fence running up and down chasing the skid steer operator. So we brought him in here. It's pretty warm outside today. It's pushing 90 degrees. So, okay, as you've noticed, I've been working on mounting the hydraulic pump. Got it done at this point. So the larger plate here, I tapped into place and adjusted perpendicular to the pump output. Used a machinist square to get square to the frame, and then I slid the coupler sleeve over the shaft and let the hydraulic pump hang on that. So it's the other side of the coupler is fastened to the shaft in the on the hydraulic pump. And I checked the spacing between the plate that the pump is fastened to and this larger plate, and adjusted them parallel in both directions, both axes. So they're coplanar, and then reduce the sleeve, loosened the pump on the sleeve and pushed the shaft into the sleeve a little bit more, brought the pump plate against the alignment plate, and I dropped a 1/4 20 bolt through the hole on the coupler here and the output shaft. I'm calling it the output shaft, but in a normal tractor that's actually input, but doesn't matter. So a couple bolts through the plate, tack welded or welded the plate to the frame, inside of the frame, both sides. So this larger plate's not going anywhere, and the smaller plate can be removed, or the pump can be removed, filter can be removed, so it's serviceable. So that's the hydraulic pump installed. I'm going to put a nut on this bolt temporarily. It's really intended for a roll pin or a spiral pin, but for the time being, for testing purposes, I'm just going to leave it as a 1/4 20 bolt. There's a safety nut. nylock nut. I'll put that on there. Okay, I think she's installed. You can crank the engine over and it spins properly. All right, folks, that's it for this week. Got the hydraulic pump installed. I need to determine which is input and which is output based on its rotation. I'll do that offline and look at the specs based on the rotation of the shaft, looking at it. So figure that out. We'll come back next week hooking that up in the circuit as a booster pump. We're going to try that. Don't know if it'll work or not. If it doesn't, we'll provide a fluid reservoir for that hydraulic circuit and separate that from the steering circuit. The steering circuit will continue to use the hydrostatic transmission auxiliary outputs, which is perfectly adequate for that application, and we'll use this circuit for the lift bed, the dump bed. So we'll come back next week working on that. Thanks for watching. We'll see you then.